Now that we have this block class, we want to make sure that it behaves consistently as we continue developing the project. Now, we can continue doing the manual dev tests and checking the console logs as we develop. But a more robust approach would be to set up a test environment for our project. That way we'll test this class as well as any other classes that we add to the project. So that way we can have nice, consistent code. An added benefit of testing is that it serves as documentation for how to use these classes and these objects. To begin, we'll need to install our test runner for the project, which is a module called jest, which means you'll need to head to the command line. So go ahead and stop the running script, and then let's use npm i for npm install. The module is jest, and then we'll save this as a development dependency with the -- save dev flag. With jest, we can execute testing files in our JavaScript project. To find testing files, jest will look for files with a test.js extension. So to test our block class, let's create a block.test.js file. So back in the code editor, we're going to install, or rather create a new file called block.test.js. In order to test our block, the very first thing we'll need in this file is access to the block class itself. So let's make a block constant that is capitalized with B, and then we'll set it to requiring the exported constant from our block module. And now we use our very first jest specific function in this file. That function is one called describe. For the first parameter of this function, we provide a string that serves as a description for these tests. Now, it's usually good enough for this description to be the name of the object or class that we're testing, which in this case is the block. The second parameter of the describe function is a callback arrow function. So we have a second parameter, which is an arrow function, and this will contain a series of tests that jest will execute once it finds this overall describe block function. And now we can set up our tests. For a unit test within jest, we use another special jest function called it. It goes right in the body of the describe function, and it's a bit similar. For the first parameter, we provide a description on what the test is that we're executing. So for our first test, let's have a test that says that the block sets the data to match the input that we give it. So we're going to have a string that says it sets the data, meaning the data attribute for that block class, to match the given input that is given once that block is created. And notice that data over here is surrounded by backticks just to signify that this is a special variable within our string message. Now for the second parameter, likewise, we have a callback arrow function, which will actually have the code to execute the test. Now let's also set up a second test. This one will do a similar check on the attributes of the block, except this time it will make sure the last hash is set properly. So for this message, let's say it sets the last hash. So again, we're going to have backticks around our last hash. And then what does it need to match? It needs to match the hash of the last block. For the second parameter of the function, again, we have a callback arrow function. Now that we have these tests set up, we need to have some objects that we can actually run the tests on. For us, we'll primarily want an instance of this block class. Now, rather than creating an instance within the body of each of these unit tests, we can use another special jest function called beforeach. Beforeach allows us to run the same code before each of the following unit tests. So I say following, so add the beforeach before each of the following tests that come after, which are our two unit tests. Now, within the body of this function, we'll create a block instance for us to use, but primarily we're going to need the data that we're storing. So let's make a new constant called data and assign it to some fake data. It can be anything, so how about a string that says bar? Then we'll assign a last block constant. Now, we don't have a block created yet, but we need one to generate a block. So for our default last block, we can take advantage of the Genesis block once again, which is the dummy default block that we created within our block class. So again, assign the genesis block to a last block constant. And now we can finally create our block using the static mindBlock function. So we're going to say that we have a local block now that is set to calling block.mindBlock with the last block as its input for the first parameter and data as the second argument. Great. So now we've set up a block for each of our following tests. There's actually one problem though with how we did this. These variables won't be immediately accessible in our testing it functions since we limited them to the scope of our before each function. What we can do though is declare the variables at the top of our describe function. So right at the top of the describe, we're going to have let data, last block, and block. And now we're declaring the variables, but we're not assigning them yet. And now within the before each, what we can do is the actual act of assignment. So we'll take off the const reassignments over here. And now we're simply saying data equals bar, last block equals block.genesis, and block equals block.mindBlock using the declared variables at the top of the describe function. Okay, great. Now we're prepared to create our first test in the body of the first it function. So right here in the body of the first it function, we're going to use another jest keyword, expect. Expect takes an object or any other piece of data, like a string, for example, as its first input. And then we can chain methods after the expect function to describe what we expect that inputted data to be. So let's expect that the block.data is going to be something, since this test is checking that the data matches our input. So then, in order to run an assertion or an expectation, to do this check, we can chain a method called toEqual. So this will now expect the block.data to equal something. And what should it equal? Well, it should equal the inputted data. So let's pass in data as the parameter to equal. So now our first test should expect that the block instance recreated has a data attribute that matches the data input. Now for our next test, we'll do something very similar. We'll have an expect function that expects that the last hash within the block is equal to the last block dot hash, meaning we'll expect the new block, its last hash value needs to equal the hash of the last block that it received, which can be found within last block and its contained dot hash value. Great. Now we have two fully set up unit tests for our overall block test file. We're ready to run this test. First up, let's add the test script and update it in our package.json file. So within package.json, head over there. Notice that there is a test script, except, well, we wrote a test, so we don't want it to say echo no test specified. Instead, we want it to run the jest runner, and then we'll give it the -- watch all option. And the watch all option is similar to NodeMon in the sense that it sets up a server that listens to changes and reruns the entire suite whenever it detects that a new file with a change has been saved. All right, great. So go ahead and save that and make sure you also save the testing file. And with that, we're ready to head to the command line and test this out. So in the command line, notice that jest should be completed and installed at this point. And then we can run the new test script with npm run test. And if all goes well, what you should find is that we have two passing check marks. So one test suite ran, which was our block test file, and then two inner tests passed as well, showing that indeed the block sets the proper data, and it also sets the proper hash. And to show that these tests are actually working, what we can do is within back in our code editor, go to the block test, and then change the data to something bad. So how about foo? And over here in this one, we'll also set it to something like bar. And as we save this back in the testing file, in the command line, notice that we have two failed tests within our command line, and both of them are saying, hey, you expected bar to be the hash, but it actually received the leet speak hash, which is the hash of our first Genesis block. And then we expected the value to equal foo for our written test, but the value it received was bar. So these tests are actually functioning as we expect, failing with the wrong data. So let's fix our test, set it back, hit Control Z a couple times to set it back to the original data, and then back in the command line now, Sorry for all of the switching, but here we are in the command line. Notice that we have a full suite just as before. Great. We now have the test environment with a test for the block class set up for our project. This will allow us to make sure our block class stays consistent as we continue developing for this blockchain project. So let's move on and extend upon this block, linking them together to create the actual blockchain.